So, in summary, the steps that are taken if we either want to use stateless DHCP or stateful DHCP, they are sort of similar. The only difference is on what information are we requesting here. If we are using stateless DHCP, that request is only for other information. It's not for the IPv6 address itself. It's for that extra information that is required. DNS server addresses. If we are using stateful, however, then this request is requesting everything from the IPv6 address and that other information. And that is what differentiates what we call stateless and what we call stateful. Stateful, we are requesting everything from the server. Stateless, only other information from the server. It's not everything. Note, server client DHCP version 6 uses UDP 546 from client to server and 547 from server to client. Right, so I think I can recognize DHCP version 4. It uses 67 and 68. So this one uses 67 and 68, with 67 being I think this should be the server. So this is the server port. This is the client port. That's how communication occurs with DHCP version 4. So if you have a client here and a server here, with version 4, the messages that we have discover, we have offer, request, and acknowledgement. So this one is sent in this direction. The port which it is being sent to, this is port 67. Then when you get this response, it uses port 68, 67, 68. So when we talk of these ports, this is basically what we are talking of. It uses two ports, 67 and 68. I think when we did module, should be 14, the transport layer, we discussed port numbers. If I'm getting HTTP services, for example, I get them when I use port 80, you need to recognize the common port numbers. I think they'll be asked in the exam, so we have other ones here. If we are using DHCP version 6, you use UDP port numbers 546 and 547. Stateless DHCP operation. If an RA indicates stateless DHCP method, the host uses the information in the RA message for addressing and contacts the server for additional information. We've gone through that. The server only provides configuration parameters for clients and does not maintain a list of address bindings. That is why it is stateless. When we talk of address bindings, we are talking of a map of every IP address and MAC address of the device. When we did DHCP version 4, we discussed the binding. So every time a host is assigned an IP address, then it is binded to the MAC address of that host. The IP address is binded to that to the MAC address of that host. With stateless DHCP, we don't have that binding. That is why we say it does not track, it does not monitor which addresses are being assigned to which hosts. With stateful, automatically there is binding because it monitors and it tracks every IPv6 address, where and to whom it is assigned to which host it is assigned to. Example, PC1 receives a stateless RA message containing the IPv6 GUA network prefix and prefix length. So when we talk of stateless, it means we have SLAAC plus DHCP version 6 when we talk of stateless. So the IPv6 GUA network prefix, this is what is being used by SLAAC to form the first 64 bits of the network. Then the other 64 is automatically generated. That is what SLAAC is. A flag set to 1 informing the host to use SLAAC. This is A, it goes to 1. The other flag or it goes to 1, meaning we'll get additional information from our DHCP server. M flag is goes to 0. We are not using stateful DHCP. This is more of a repetition. Enabling stateless DHCP on an interface. How do we enable an interface to provide stateless DHCP version 6 address configuration? So if you have a router and you want its RA message to contain this is stateless, to contain A is equals to 1, O is equals to 1, and M is equals to 0. You will need to configure this. By default, every router, not every routers, let's just say routers in general, by default they use SLAAC, meaning A is equals to 1, O is equals to 0, M is equals to 0. That is what it uses by default. If you want to add another option, which allows that router to enable stateless DHCP, then you need to configure that command. If we have this command, then it means we have now option 1 and option 2. Option 1 is the default. Option 2, we say A is equals to 1, O is equals to 1, M is equals to 0. So to enable stateless auto configuration, you need to input that command. Stateful DHCP. If an RA indicates stateful DHCP, the host contacts the server for all configuration information. I think we've gone through this. For stateful DHCP, you get everything. You get the IPv6 address. You get the global routing prefix, the network portion. You get the host portion. You get the default gateway. You get the DNS settings. You get everything from the server. That is what stateful DHCP is. In terms of flags, M flag is set to 1. O flag, it can be 0, it can be 1. It will be overridden. Here they're saying O flag set to 0, informing the host to contact a DHCP version 6 server. It can be 1, it can be 0. Because everything will be overridden by this M is equals to 1. Here it's not being highlighted, but it can be either ways. Because if it's 1, it means we're getting extra information from the DHCP server. It is 0. We are not getting anything from the DHCP server. However, if M is equals to 1, it overrides everything that is here. Because you are definitely getting everything from the DHCP server. And obviously our A becomes 0 because we are no longer using SLAAC. There is no auto configuration there. Enabling stateful DHCP. So by default, we've enabled A, let me put it this way, A or M. So by default, we use SLAAC only. our flags will be like this. This is the default state, number one. Then we've discussed number two, which is stateless DHCP, which is enabled by the command IPv6 ND. It should be other command, the other config flag. That is the command which is used to enable a stateless. And when that is done, it allows us to have option number two, which is like this. Then option number three comes in if you input this command. This allows us to have our flag M is equals to 1 and our A is equals to 0 like this. So this is now stateful. By default, I repeat, by default, it is not enabled. What is enabled by default is SLAAC only. DHCP router roles. A router can either act as a server, which provides DHCP version 6 services. So it basically provides addresses to other hosts. A router can also act as a client. We discussed this with version 4. A router can get its IP addresses from the ISP. So let's say we have an ISP which is configured to provide addresses dynamically. Then a router we will have to be configured as a version 6 client, DHCP version 6 client. Why? So that it is then able to get an address from the ISP. A router can also act as a relay agent, which allows it to forward messages from within a local link. So a router can play those three roles. How do you configure a router as a stateless DHCP? Number one, you need to enable IPv6 routing using this command. I think you definitely see a lot of this command. If you want to deal with IPv6 routing, you need to enable it on a router. By default, it is not enabled. You need to enable it. So you enable IPv6 unicast using that command, IPv6 unicast routing. Then after that, you create a pool. When you create a pool, it will get you into the DHCP configuration mode, where you can then add these options, the DNS server, the domain name. I think we discussed, it's sort of similar with what we discussed with the version 4. When you create the pool, then you add the server. Here you only add the server and the domain name. After that, you bind the interface with the pool. Right. You then need to manually change if you want to configure it as a stateless DHCP. Then you need to change how the flag values are going to be. So our O flag will need to be 1 because we're using stateless. Our A flag will need to be 1 because we are using SLAAC as well. And obviously our M flag will need to be 0. Will need to be 0. So you need to manually change that. How do you do that? By using these commands that we've just gone through here. Where are they? These ones. This is how you manipulate those values. Changing, you use these values. That's how you change the values of those flags. Use those commands, Right. Then verify that the hosts have received addressing information using the IP config O. Here we've already configured our server. We're just checking if devices are getting addresses via a stateless DHCP. If we want to configure a stateless DHCP client, Number one, enable routing on the device. Enable IPv6 routing on the device. Number two, create a link local address on the device via two ways. You can either create a link local address by first creating a GUA. So if you create a GUA, then a link local address will automatically be there. Or you can use this IPv6 enable interface configuration mode, which allows the router to create its link local address automatically without needing to create the GUA. So to configure our device as a stateless client, one, we enable the routing. Two, we configure the link local address. How do we configure that? One, you just configure the GUA and we get the link local address automatically from that. Or two, you go and use this command without creating the GUA. Then after that, we configure the client to use SLAAC to get its IPv6 address. This is the command. IPv6 address autoconfig. It means now our device is getting its address using SLAAC. From these ones, these are just show commands which we can use to verify if we've actually gotten an IPv6 address. I think we are definitely going to have a lab. These are very simple concepts. In theory, they seem complicated, but this is nothing. Configure a stateful DHCP server. If you want to configure your router as a stateful DHCP server, same process. You enable routing, you create a pool, you add the options, you bind the pool, then you manually change the flags. When we talk of stateful, then our M will need to be equal to 1. Then our A will need to be equal to 0. This is very important. That's how you configure a router as a DHCP server. Definitely need a lab. After that, you verify using that if devices are getting addresses. Configuring as a stateful client, same thing. The only difference here, instead of getting an address from SLAAC using autoconfig command, here we use DHCP. So you configure on your client. I want my client to use DHCP to get his address. Here, we used autoconfig, meaning our address was coming from auto configuration, which is stateless auto configuration. Here, our address is coming from DHCP. That's the only difference. So that's how you configure a client to get an address from a stateful DHCP. Then verification, you're just verifying if you've got an address. Other show commands. The show IPv6 DHCP pool, it verifies the name of the pool and its parameters. What are the options that you have? Here we have our DNS server, we have our domain name, additional information, what are the active clients that we have there. These are just verification commands of what you would have configured if you wanted to configure a server, either stateless or stateful. Another verification command which shows the binding that we have. Where are the addresses? I don't see them. Username unassigned. Right. This one displays IPv6 link local addresses of the client and the GUA addresses assigned by the server. Information is maintained by a stateful DHCP server a stateless DHCP server would not maintain this information. So binding here, it has the link local address for IP. For IPv4 binding, it uses the IP address and the MAC address. Here, I'm realizing it's using the link local address, FE80, and the GUI address, this one. That is what binding is with IPv6. I need to confirm with this one. Show commands, show commands. Configure DHCP version 6 as a relay agent. How do you configure our router to forward messages? Command IPv6 DHCP relay, then you put the destination where the information is supposed to be going and the exit interface. It's a bit different from the one we did with DHCP version 4. The command is a bit different. With IPv4, we entered this interface and we just configured the address of our server, and that was it. Here, you need to specify the exit interface. What is the exit interface? That will be used by the router to send or to relay the messages, basically. This one will need a lab. All right. Verify the DHCP relay agent, another show command, which allows us to see if a router is acting as a relay. So here we have our relay destinations, this one via, this is our exit interface. Then we are done. We have time for a lab. I think I'll need to prepare another session which will basically go through this last part of verifying, of creating a stateless or a stateful DHCP server, then watching the process of automatically assigning addresses either by stateless or by stateful, comparing those two, then obviously looking at the show commands which were at the end here. I think this one in theory, it looks as if it's a bit difficult, but in practice, these are smalls. And basically, I think this is DHCP version 6. In summary, I think you need to know, one, when you talk of dynamic assignment of addresses in DHCP, we talk of three methods: SLAAC, SLAAC with stateless DHCP, and stateful DHCP. When we talk of stateless, when we talk of stateful, we're talking of if a server is tracking the addresses it is assigning, or in general, if it is tracking addresses. Because with stateless, the DHCP server does not assign addresses. It just provides additional information. It does not track. With stateful, it provides for everything, the addresses plus the additional information, and it tracks every address that has been assigned. So you need to know those three methods and what they mean. You need to understand those flags. If I'm using SLAAC only, what are the values of the flags? Our A is equals to 1. If I'm using stateless DHCP, then our A and O are equal to 1. If I'm using stateful DHCP, then my M is equal to 1 and my A is equal to 0. And if you manage to understand that, add a little bit of the communication between the client and server with respect to the exchange of RA and RA messages, what is happening. Then, furthermore, if I'm using stateful DHCP, there is a further exchange of messages after the RS and RA. The solicit, the advertise, the request, and the reply. You need to understand that as well. And I think with that, DCP is not much an issue. Tomorrow, inshallah, hopefully we can have a lab. It will probably be less than 10 minutes, I think. Right now, I'm losing my voice. Let's call it a day. Tomorrow, we continue there and we go to chapter number 9. Any questions? What do we have on module 9? Any questions? What's on module 9? That's my question. Yeah, Mr. Lloyd is still here. Module 9 energy. CCNA.